Welcome back, enthusiasts. In today's video, we'll explore the captivating world of cannabis cloning. Whether you're a seasoned cannabis aficionado or an aspiring cultivator, grasping the science behind cloning can greatly enhance your growing experience. Cloning cannabis plants. Cloning, also known as asexual propagation, is derived from the Greek word clan, meaning a twig or slip. Primarily embraced by traditional growers and breeders, cloning aims to preserve a cannabis plant's specific genetic traits. The exact timeline of cannabis cloning's broader implementation remains somewhat obscure. However, its ascent gained momentum with the surge in indoor cultivation operations and the escalating demand for consistent, high-quality cannabis strains. Cloning provided cultivators with a dependable means to replicate plants possessing desired attributes like potency, flavor, and growth traits, bypassing the unpredictability of seed propagation. By the 1980s and 1990s, as cannabis breeding and cultivation techniques evolved, cloning became increasingly popular among both hobbyists and commercial enterprises. The rise of hydroponic and indoor cultivation methods further propelled its adoption, offering growers more controlled environments conducive to maintaining genetic uniformity and optimizing yields. Since then, cloning has become a staple in the cannabis industry, seamlessly integrated alongside seed propagation to ensure uniformity in crops and preserve coveted genetic characteristics. Technological advancements, such as the development of specialized cloning gels and propagation equipment, have augmented its efficacy and accessibility in cannabis cultivation practices. Several notable individuals and organizations have significantly contributed to the refinement and dissemination of cannabis cloning techniques. Figures like Mel Frank, renowned for his expertise in cannabis cultivation, and Ed Rosenthal, celebrated as the guru of ganja, have played pivotal roles in educating and popularizing cloning methods. Legendary breeders like DJ Short and Nevil Schoenmakers have further advanced cloning techniques through their groundbreaking work in developing iconic cannabis strains, solidifying the foundation for modern breeding programs. Now that we've covered some background on today's topic, I want to take a moment to thank the sponsor of today's video, Mars Hydro. As much as I like being hands-on in the grow room, the truth is life sometimes gets in the way, and that's where Mars Hydro comes in. Since 2009, Mars Hydro has been focused on making indoor lighting and equipment more accessible to growers. One of their products that I think could be helpful to both new and longtime enthusiasts is the FC6500 730W LED grow light. The thing that I really like about this product is that it's not just about raw power, it's about control. The FC6500 uses Bridgelux 3030 LED chips, giving growers strong light output with solid efficiency. It also includes a full-spectrum design with Osram 606nm deep red chips, which can be especially useful as plants move into the flowering stage. But a grow light can have great specs on paper and still perform differently depending on how that light spreads across the grow space. That's why one of the most important things to look at with any grow light is the PPFD distribution map. Because if the center of the grow is getting blasted, but the edges are falling behind, you can end up with uneven growth, stretched plants, and inconsistent results. And once you have that more even coverage, the next step is being able to adjust that light as the plant moves through each stage of growth. That's where the smart control side becomes really useful. When paired with Mars Hydro's smart controller and PPFD sensor, you can schedule dimming and adjust light intensity. You can also use this type of control to mimic smoother transitions, like sunrise and sunset, instead of suddenly blasting plants with full intensity the second the light turns on. That can help create a more stable lighting environment, which is especially useful for growers who are trying to avoid stress and keep the grow room consistent. So whether you're trying to upgrade your grow light, improve canopy coverage, or make your grow room a little more automated, check out the Mars Hydro FC6500. And if you decide to pick one up, you can use discount code GUY for 3% off. Thanks again to Mars Hydro for sponsoring today's video. Now let's get back to today's topic: how to clone cannabis. Although we can't cover them all, we'll delve into two of the most common ways that growers clone cannabis plants: vegetative propagation and tissue culture propagation. Let's start with the most common method: vegetative propagation. Cannabis vegetative propagation, commonly known as cloning, is a method used to produce genetically identical plants from a mother plant. This process allows growers to maintain specific desirable traits such as potency, flavor, and growth characteristics. Here's a detailed breakdown of the cannabis vegetative propagation process. 1. Selecting the mother plant. It's crucial to start with a robust mother plant that exhibits desirable traits, selecting it based on its genetics. This entails choosing a healthy specimen devoid of any pests or diseases to ensure the genetic integrity of the clone. Additionally, the mother plant should ideally be in the vegetative stage, as this stage offers the best conditions for successful cloning, promoting rapid growth and robust root development in the clone. 2. Preparing the cloning area. Maintaining a clean environment is essential and necessitates the sterilization of tools and the workspace to prevent any contamination that could compromise the process. Adequate humidity levels, typically between 70 to 80%, are crucial in the cloning area to provide optimal conditions for the development of new clones, promoting their health and vigor. When it comes to lighting, using low-intensity options such as fluorescent or LED lights helps prevent undue stress on the clones, ensuring they can focus their energy on root development and overall growth. 3. Taking cuttings. When preparing to take cuttings for cloning, it's essential to use precise and sterilized tools, such as a sharp razor blade or scissors, to ensure clean cuts that minimize damage to the plant tissue. Optimal cutting locations are healthy branches, ideally chosen from the lower sections of the plant, where growth tends to be more vigorous. Employing a proper cutting technique involves making a clean 45-degree cut just below a node, the point where leaves attach to the stem. Each cutting should measure between 4 to 6 inches in length and include at least one set of leaves, facilitating successful root development. 4. Preparing the cuttings. After making the initial cut, it's important to trim the lower leaves to prevent rot and decrease transpiration, which can help conserve the cutting's energy for root development. Next, dipping the cut end of the cutting into a rooting hormone solution can stimulate root growth, enhancing the chances of successful propagation. Once treated, the cutting is carefully inserted into a suitable growing medium such as rock wool, peat pellets, or a cloning machine. It's crucial to ensure the medium is moist but not waterlogged, providing the optimal environment for root development without risking rot or suffocation of the cutting. 5. Providing optimal conditions. Creating an ideal environment for clone development involves several key factors. Placing a humidity dome over the clones helps to maintain high humidity levels, which are crucial for their initial growth and establishment. Additionally, it's important to regulate the temperature within a range of 70 to 75 degrees Fahrenheit, ensuring optimal conditions for root development and overall health. When it comes to lighting, employing an 18-6 light cycle, providing 18 hours of light followed by 6 hours of darkness, supports healthy growth patterns, allowing the clones to photosynthesize effectively while still providing necessary periods of rest. 6. Monitoring proper care during the cloning process is crucial for ensuring successful development. When it comes to watering, it's essential to keep the growing medium consistently moist, but avoid oversaturation, which can lead to root rot. Misting the clones regularly can assist in maintaining humidity levels, promoting healthy growth. As the clones mature, gradually increasing ventilation helps to acclimatize them to their environment, reducing the risk of mold and encouraging sturdy growth. Monitoring root development is key, typically occurring within 7 to 14 days after cloning. 7. Transplanting. After patiently waiting for root development, typically within a span of 2 to 3 weeks, the clones are ready for the transplanting phase. This pivotal step involves carefully transferring the young plants into their designated final growing medium or pots. It's crucial to handle the delicate roots with utmost care during this process to prevent any damage that could impede their growth. Benefits of vegetative propagation. Cloning offers numerous advantages for growers. Firstly, it ensures genetic consistency, as clones are exact replicas of the mother plant, guaranteeing uniform growth and consistent characteristics. Additionally, clones bypass the seedling stage, accelerating the overall growing cycle and leading to faster maturity. This not only saves time, but also resources, contributing to cost efficiency in cultivation. Moreover, cloning reduces the reliance on seeds, enabling growers to perpetuate their best-performing plants and maintain a desirable genetic lineage. These benefits collectively make cloning a valuable technique for maximizing productivity and quality in plant cultivation. Tissue culture propagation. This method involves using small plant tissue samples, such as stem cells or meristem tissue, to generate new plants under controlled laboratory conditions. Tissue culture offers several advantages over traditional propagation techniques like seed germination or cloning from mature plants, primarily by enabling the production of genetically identical plants on a large scale in a controlled environment, ensuring consistency in quality and traits. Now that we have a grasp of what tissue culture propagation entails, let's delve into how it's done. First, the grower will need to collect healthy and disease-free plant material. Meristem tissue, the actively dividing cells found at the growing tips of shoots and roots, is often preferred due to its high regeneration potential and genetic stability. Next, the selected plant material undergoes surface sterilization with a disinfectant to remove any contaminants such as bacteria, fungi, or viruses. Following the sterilization process, the plant material is then placed onto a nutrient medium containing plant growth regulators such as auxins and cytokinins. These hormones stimulate the growth of new tissues and encourage the formation of shoots and roots. Once the initial cultures are established, they are transferred to a multiplication medium optimized for rapid growth and multiplication of shoots. This stage involves subculturing the plant tissue onto fresh medium periodically to maintain vigorous growth. After achieving sufficient shoot proliferation, the plantlets are transferred to a rooting medium to induce root formation. Rooting hormones such as auxins are often added to facilitate root development. Acclimatization. Once roots have developed, the plantlets are gradually acclimatized to ex vitro conditions by gradually exposing them to ambient humidity and light levels. This helps them transition from the controlled environment of the lab to the outside environment. And there you have it, a comprehensive guide to cannabis cloning from its historical roots to practical implementation. Whether you're a novice grower or a seasoned enthusiast, understanding the science behind cloning can elevate your cultivation skills and produce bountiful yields. Thanks for watching. Don't forget to like, subscribe, and hit the bell icon for more insightful content on cannabis cultivation. And remember, if you have any questions or suggestions for future videos, leave them in the comments below. Thanks again, and until next time, keep being awesome and stay curious, my friends.